Working on our battery balance monitor again. This one is a 24 volt version for 24 volt battery packs. So I use two yellow lights and a green light. That way I can tell easily this is for 24 volts. So I've got our two resistors in here, our center pack tap, our minus tap, and our positive tap, all in a cool little box here. Got a lid we'll put on it after we make sure everything works properly. We're going to test it out and make sure it works here. We've got our little 12 volt light bulb. We're going to hook up to just one battery to create an imbalance and go from there. So to get some data, our first battery here is showing 13.3 volts, and we're showing right between 13.1 and 13.2. So I guess they're closely balanced. Connectors together, ground's on the negative, positive taps on the positive, meter showing 26.5 volts. Now we've got our balance monitor hooked up. Got the center tap going to the center, negative going to the negative, positive going to the positive, and the green light is on by itself. And just for a quick test, if we unhook the negative lead, the yellow light comes on, hook it back up, and if we unhook the positive lead, that yellow light comes on, hook it back up. So I believe we're all hooked up properly according to the diagram here. And now we'll hook up our light and create an imbalance. Alrighty, got our 12 watt or 12 volt light bulb hooked up to battery number 1. We're still showing imbalance, and the time is 9:45 a.m. So let's test this and see how long it takes to get out of balance. Well, it's been about 3 hours now, and we're still not showing any type of imbalance. Had the light going steady, like I said, 3 hours now. And just did a check with our meter here. And battery number 1 is showing 11.8 volts. Battery number 2 is showing 12.9 volts. And together they're showing 24.7 volts. So we're showing a decrease in voltage, and even a difference in voltage. It's only about 1 volt difference, so we're not showing even a little bit, nothing. So we'll check it again in a half hour. 4 hours later. Well, it's now 1:45. So we've had this light on, just battery number 1, for 4 hours now. And we're showing a slight imbalance, it looks like. Let me shade it a bit. Yes, we are showing an imbalance on the first battery finally. So let me do a quick test and see what our meter shows at. Battery number 1 is at 11.3. Battery number 2 is at 12.9. There's no change there. And together, both battery packs are at, or both batteries are at 24.1. I'm shading it a little bit here, but yes, that's definitely the right yellow LED is definitely lighting up a little bit. Now we are down to 11.3. So that's almost a 2-volt drop to finally showing imbalance. The second battery, battery number 2, started off at around 13.1 or 13.2, not for sure. And now it is showing 12.9. So it dropped just a bit. And then looking at my numbers here. Overall, we started off around 26 volts, and now we are down to 24.1. So we seem to be showing an imbalance, and on this side of the battery pack. I'm gonna let it go for just a bit more to get a little bit more data. So we'll be back. Alrighty, it's about 2:15 now, so it's been about 4.5 hours now, and our bulb is noticeably dimmer. Our yellow light is on noticeably brighter, green light's on full, and our first battery is all the way down to 6.8 volts, 6.7. Overall, our batteries are down to 19.5. So we've discharged this battery quite substantially to show an imbalance. Well, it's been about 15 minutes since I disconnected the light load that I had connected to battery 1. Our balance monitor is no longer showing an imbalance, and battery number 1 here has recovered to 12.1 volts. I haven't done any type of charging or anything. All I did was unhook the 12-volt light. And then we checking the overall battery pack voltage. We're up to 25.6. We've got our battery balance monitor here. I'm going to seal it up with some clear silicone. Keep all of our guts protected and everything before I put our little cap on. Here's the butter knife to mush most of our silicone in. I'll squirt a little bit more to fill in some of these gaps. Let it set up. Alright, I put another layer of our silicone in. Just have to smooth it out a little bit. Kind of tuck it down in the nook and crannies, and that should be good. Alrighty, I got her about 3/4 of the way filled up. I guess you would say that's fully potted. Let that set up and cure overnight. And I'll snap the lid on and we'll be good to go. Well, I've got her all filled up with silicone, and it's cured overnight. I'm going to snap the lid on, and our 24-volt Batt-Bridge should be completed. Well, there's our 24-volt Batt-Bridge all done and together. Pretty heavy duty. I think it'll do the job quite well. And while I was making this thing, I come up with a couple more questions and learned a few things. So discuss that a little bit, I guess. I drew out Hart's Batt-Bridge diagram, and then the formulas example. But just to point out, squiggly thing here is a resistor. Those are both power resistors. These three things represent our LED bulbs. Also, LEDs stand for light emitting diodes. So these are all symbols for diodes also. They're diodes that emit light. So unlike regular bulbs where you can hook them up either way and they work, diodes are like one-way electronic valves, I guess you would call them. So each one has a plus and a minus. So all of these diodes, these points, mean something. So on our plus, our positive line that goes to the positive pole of the battery pack, you would have the positive line of one of your red diodes and the positive line of your green diode. And then on the other side of your green diode, you'd have the negative line of your green diode and the negative line of your red diode. Then going to your center tap, you'd have the negative off of your positive red LED, I guess you would call it, and the positive off your negative red LED, I guess you would call it, come together to your center tap. So all these LEDs have to be in the correct order for this to work properly. And then to figure out what resistors you need, you start off with whatever your pack voltage is. That would be represented as X. You want half of your pack voltage because you're measuring each half. So it would be X divided by 2 equals Y. So we got Y divided by 0.15. That's about what we want milliamps, right in the middle of between 10 and 20 milliamps, equals Z. And then Y times 0.015 equals, I guess this would be ZA and ZB. ZB. So then you figure out, that's how you can figure out what resistors you need. And then you want to double up the wattage represented by ZB because you want enough watts to handle the whole pack, I guess you would say. And then you want your power resistors to be at 1% tolerance. So as an example, for the 24-volt battery balance monitor, we've got a 24-volt battery pack. Half the pack is 12 volts. 24 divided by 2. 12 divided by 0.015 equals 800 ohms. That gives you your ohms. And then 12 times 0.015 equals 0.18 watts. That gives you your watts. And then you double up your watts. That's almost 20, so 20 and 20 is 40. That's just under a half a watt. So you would need an 800 ohm, half watt, 1% power resistor for a 24-volt battery balance monitor.